Lauren had that thing at the hospital.
It trips me out that he has kids because he seems young. He looks so young.
I know. It's crazy. I in my last ward, I was living out in DC, and so I was 30 before I got married, and it's kind of crazy. Like you just assume that people have kids or old, and all these people I assumed were older than me were like 6 or 7 years younger than me, and it was really tripping me out.
That is funny.
Yeah.
Okay.
So I actually started the quiz already.
Okay.
While we're waiting, I think it's gonna be pretty easy.
Yeah, it looks really easy. Do we? So 3 is C.
Let's see. 3 is C, and 4 is C.
Isn't this one the sample proportion?
I think because it doesn't have that symbol over the top, I think it's the true. But let me just look real quick into the notes. Yeah, so regular P is the true population proportion.
So the true.
The true proportion, yeah.
Okay. And then number N is the sample size, right?
Yep.
And then, so we need at least 30, right?
P is. I think in this one it's like 10, right?
Oh, okay. So then would it just be 40? I'm gonna look that up real quick.
So we have to. Yeah, it just has to be greater than or equal to 10.
So would it be 40 then? Is that like good logic on that, or?
I think it's just 10.
Well, why is it equal 1/4?
That's just saying. I don't know. Let me look in the notes. Oh, let's see. N times 1 minus P. So basically, it would be. How do we find this? So N times P has to be greater than or equal to 10. Let's see. Yeah, I'm not sure on this one. This is confusing me because smallest N.
So it's saying that. But I don't get how it's set equal to. Where he says. Because if you look at, because P, you see, are you in the book?
Yeah.
When it says the mean and standard deviation 3.2.2 or whatever.
Yeah.
So if P equals 1/4, would we have to like find all that stuff? Is that what they're wanting us to do?
Um,
But I don't
is
get,
it-
that's a
we're
standard.
trying to, yeah, because we're trying to find what we'd have to solve for whatever n is.
Because it's saying, what is this? But I don't get how it can satisfy it. Wait, what?
Because I'm just looking at how large is large enough. And I guess n times p has to be greater than or equal to 10. So what is the smallest n
Oh,
times 1/4 that will get us to 10 at least?
so wouldn't you
So,
just work it
oh,
backward?
you know what? You know what? Maybe it is 40. 40 times 0.25 would be 10, right?
Yeah.
Yeah, dude, you were right all along. It's 10.
Okay. Or 40.
Or 40, yeah. Sorry, man. I made that a whole lot more confusing. You had the answer all along.
That's good.
So, n is 24. The mean of p equals p.
Huh?
So it's just 0.4.
Is it really?
I think so. If the sample proportion p with that thing over the top is normally distributed if n is large, which means larger than 10, the true proportion mean of the random variable p is the mean of whatever that variable p equals p.
Oh, okay.
And n is greater than 10, so I would say that the mean is just 0.4. Standard deviation is p times 1 minus p over n, and then the square root of that. So we have 0.4 times 0.6. .24, divide that by 24, 0.01, and then the square root of that is 0.1.
The 0.1 is the answer. That's a standard deviation.
Yep.
Okay.
Let me try that again. So p times 1 minus p. So p is 0.4. So 1 minus p is 0.6.
Huh.
So 0.4 times 0.6, 0.24, divided by n, which is 25.
And then square root.
Did I do that wrong? It's not 25, it's 24. So yeah, and then you square root. So 0.4 times 0.6, 0.4 or 24 divided by 24 is 0.01. Then take the square root of that. Yeah, it's 0.1.
Okay. And then to find P. So the P is, we're not trying to find the standard deviation of it, or
Yeah, that's the next question. So as long as n is sufficiently large, then the sample proportion is the same as the total proportion. So it's just 0.3, I think.
really? If it's over 10?
Yeah, I mean, that's what it's saying. So
Where's that in the book?
3.2.1.
Oh, I'm right here. Where does it say that?
3.2.2. The sample proportion of P is normally distributed if n is large, and n is large in this case if it's greater than 10. The true population mean of the random variable P is P.
That's the mean, right?
That's just
That's
the mean.
But that's
Yeah.
not that. That's not P.
But it's the same thing.
It is?
Yeah. They equal each other. If they give us P as 0.3, then
Because P is the population mean.
Mm-hmm. Yeah, P is the true mean, and then the sample mean, if the sample size is high enough, is the exact same.
Okay.
Because this is like we're doing a lot of assumptions
Yeah.
in this stuff.
And so then now we have to find the standard deviation, which is the same thing we just did.
Yeah, so it's 0.3 times 0.7
over 100 square rooted.
0.046.
That's what I got. Z-score is the value. What the heck? Oh, so we use that number. So we could just put
0.046 in the normal probability applet.
Oh, no.
Is it not?
Okay. Well, because it looks like that the Z-score on this one's a little different.
Oh, that's right. The value minus the mean over the standard deviation.
But we already calculated the standard deviation, right?
Yep.
Which is the 0.046. So we would just put the value over the mean.
So it's the mean minus the sample mean. Which is
so
it's 0.300 minus 0.3.
I think that
What the?
Well, do you think that we should be doing I think it's 0.35 because we're trying to find out the probability that she will get more than 35 hits in her next 100 at bats. So that would be the new value.
Let's see.
Does that make sense?
Yeah, I wasn't even reading that part.
So would that change our other answers too?
Probably.
Well, because it says that I think it would just change it to P would be 0.35.
Yeah. And so then the standard deviation of that, I'll have to redo. So
Well, don't we just do the standard deviation would be the same, right? Because we're using P in the calculation.
We were using P and not like the sample P. We were using 0.3.
Well, yeah, but we don't. In the book, it just says you just use P though.
Oh, because they're the same.
I'm assuming. Well, it doesn't. It just says. I don't know why it says that, but.
Oh, okay. I see what you're saying. Standard deviation of that is the regular P. So yeah, so that should be the same. Okay.
And then, So I think the only thing that changed is the 0.35, if I'm not mistaken. But does that sound right to you?
Yeah, so then we do 0.35 minus 0.3.
3 should be 0.05 divided by
0.046.
0.046.
1.087.
0.087.
That makes a lot more sense. And so now we put that into the normal probability applet.
Mm-hmm.
And we want it more than that, so it's the right side. So 0.139.
Well, wouldn't it be it gets at least 35 hits?
Oh,
So would we select the middle and the right side?
yeah, you're probably right. So 0.862.
Okay. I know. I hope not. I'm not wrong on that.
Well, it's all good.
Does that sound right though?
It does. Let me see if I can find anything in the book that confirms that. It says next we enter the z-score in the normal probability applet and shade the area to the right of this value.
Okay. So it wouldn't be the middle.
That's what. Yeah, I think so.
Okay. So just the right, right?
That's what it's saying.
So then what would be the value?
0.139.
That seems weird to me. Because her normal average is 300.
Mm-hmm.
Oh, but I guess that's right. That would make sense. It wouldn't be 8 because that's saying it would probably happen, but it's saying that if she's had a 300 average.
Yeah, she's got a 13% chance of getting at least
Of going.
35. Yeah.
That makes more sense than 80% chance.
Yeah.
Okay.
All right. So standard deviation of this thing.
So it'd be P, which is 0.52 times 0.58 or 0.48, right?
Yeah, I think so.
Divided by 2,000.
Wow. 0.000.
What the heck? Is that right?
Could be. I know I got a couple of those, like in the last homework. There was a couple of those questions where the answer was 0.000.
I got one of those on the test. Did you get that?
I think so.
Oh, okay. so weird to me that Lauren failed that test.
I know. I was pretty surprised.
He must have just used the wrong tests, I guess.
Yeah, that's what it sounds like.
But he's way smarter than me, and he killed it. And I got a B, so I don't know.
Yeah, Mike said he got a B as well.
The Z-score.
What was that formula again? P minus P.
So it'd be 0.5. We want to determine the results of the survey suggest that the candidate is losing the election getting less than 50. So would it be 0.5 minus 0.52?
Would have to be less than 50%. So do we do would it be like 49 minus or 0.49 minus 0.52? Because that's like just less than 50. I'm trying to look in the book and see because they have because in the book they do almost the same thing, but they do the different thing. So they want to know if the candidate will win more than 50%.
So what number do they use for that?
They use 0.5 for that. Because in this one, their candidate, the P equals 0.48 and N is 1,041. And so the sample of P, they use 0.5 minus 0.48. But that's because they want to find the probability of P being greater than 0.5.
So, but they still use 0.5 though.
They did.
Because there's no way that we could decide what they wanted us to do it as if it's not 0.49. You know what I mean?
So let's just do 0.5 minus 0.52.
Okay. But we're gonna have to find that real number though, huh? Again.
And, for the standard deviation.
Yeah, I'll tell it to you real quick.
It's 0.000124.8.
Okay.
What? Negative 160? I don't think that's right.
Let's see. Well, I think that that's true. We want to determine the probability that the results of the survey will suggest a candidate is losing the election. So how could he be losing the election if he has 52% of the votes?
Yeah, that's true.
So it would be a negative probability, wouldn't it be?
Yeah, that's what it's looking like.
Because if he has the majority, then there's no way that he could be losing.
Yeah, so that just seems like a crazy z-score, negative 160.256.
160.256. I'll submit it first, and we'll see.
We thought this one would be easy, but man. What is the probability the survey results will show the candidate is losing even though the true P is 0.52? So that means we take the z-score into normal probability. 0 times 10 to the 0.
Oh.
Basically 0. It's just 0.000, I think. There's a 0% chance.
All right, submitted it. Okay. Number 12. Oh. Okay. Number 12 is 1.091.
How?
We are super close on that.
Okay.
Number 14 is 0.011. Number 15 is negative 1.79. And number 16 is 0.036.
What the heck did we even
I don't
do
know.
wrong? So what did you get? What did you get?
A C plus.
Dude, I'm sorry.
It's all good. We were in agreement with, or at least I thought it was all good. So
This is a rough one.
yeah, better than the grade Lauren and Michael got on it though. So I'm happy.
This is true. That is true.
All right, we'll figure it out.
Yeah.
It looks like the whole class didn't do pretty good. So because it looks like all the real scores were like down here, and then
Yeah.
it looks like everyone did what we kind of did. Because there's like a bunch of hundreds, and then there's like F's and C's.
Yeah.
So I don't know.
All right.
We'll check and see what happened with that. But
All right. On Thursday, we got to talk about our group project because we have to submit the first part by Saturday.
okay, sounds good. It's
All
like
right.
it's just like a
We just have to design like some kind of survey or statistical something.
Can we have to actually do the survey?
Yep, that's the next part. Like in week 12, I think it is. We actually have to collect the data, and then we'll have to analyze it and do all that kind of stuff.
Because I did an internship that was exactly like that. So I have a bunch of data from that. But if we have to collect it, it might look suspicious.
Yeah, we definitely have to collect it, but we could do something similar. If you've already done something like that, we could figure out something similar to do.
I think it'd be easier if we just did like a family. You know,
Yeah.
My project was like business acquisitions, and then like I had one was like snowmobile, all the snowmobile dealerships in the United States, like profile. So it's gonna look like the teacher's gonna be like, "What the freak is this?"
Yeah, no, we'll talk about it on Thursday and we'll figure out something simple to do.
Okay.
But,
All right, sounds good.
All right, thanks, dude.
All right, see you, man.
See ya. Have a good night.
You too.